Hello there. Let's go ahead and get started on section 1.4, which is solving linear systems. We're going to change things up a little bit because um, there's a lot of work that we're going to actually have to do to solve some of these problems, and there's just not enough space in the student journal. So if you're used to using the student journal in Kami, you want to probably get a new sheet of paper this time around. What we're taking a look at right here is three equations with three unknowns, and we're going to try to figure out how to solve them and figure out where do those three lines intersect, or equations is kind of the idea. So you see right here a series of steps in order to solve three variable systems. They try to break it down as easy as possible, but they may not understand it until we actually do it together. So step one is rewrite the linear system in three variables as a linear system in two variables by using the substitution or elimination method. I personally, probably in a lot of these problems, it's easier to use the elimination method rather than substitute. So most of the problems, I'm going to show you how to use that. Um, we don't have any way for us to solve three different variables. So what they're saying is, let's take the two equations and let's eliminate. So that'll allow us to take away one of the variables. And then we're going to take another two of the equations and do the same thing. Now make sure that if you decide to eliminate, let's say x in the first two equations, or you better make sure you eliminate x again in the second two equations that you decide to use. Step 2. It says solve the new linear system for both of its variables. Step 3. Substitute the value found in step 2 into the original equations and solve for the remaining variable. So as you're working on this, you're going to start off with three variables, and then you're going to have two variables. And then lastly, you're going to only have one to solve for. A few things to take note of as you're solving these out. I'll see this often in tests, and even like PSAT, SAT type stuff, is when you obtain a false equation, such as 0 equals 1. In any of the steps, the system has no solution. So let's say like I take the first two equations and I'm using the elimination method, and I end up with something like 0 equals 1, or something that is false. It could say 5 is equal to 10. We should know that that is not true. So that happens, then there is no solution. The last part right here says when you do not obtain a false equation, such as an identity as 0 equals 0, the system has infinitely many solutions. Meaning if there's three lines, all three lines are on top of each other. That's why every single answer is going to be correct. So let's figure out how to do this. Let's take a look right here at example 1. We have three equations, three unknowns, x, y, and z. And what I see right here, the easiest way to do this, in my opinion, is to use the elimination or addition method. So that's something you're going to want to make sure you look up on or refresh your memory if you forgot how to do that. Okay, but I'm going to talk about it right now anyways. But if you need more help on it later on, then that's what you should do. Alright, so now I want to take two of the equations, and I'm going to start off by setting them up by placing them on top of each other. I want to go ahead and start off and take equation 1 and 2. And I want to go ahead and rewrite it right here. We got x minus 2y plus z is equal to negative 11. And then below that, I'm going to go ahead and put 3x plus 2y minus z is equal to 7. Now, for me, the reason why I'm doing that, because I look at this and I know that I could eliminate the z's. Remember, the elimination method is also called the addition method. So I'm going to go ahead and put that plus sign there, because I'm going to add things together. And look at the z's. If I add the z's together, that automatically will eliminate things. And when the numerator happens to, or the top equation happens to have a positive and the bottom one has a negative, then it's much easier for us to add things together and realize it equals 0. So that's part of the reason why I set it up where I put equation 1 on top, equation 2 down below. Now, you could put equation 2 on top and equation 1 below it, and you'll still get the same result. It's just making sure that you do the math correctly. So I want to go ahead, let's add things together. X plus 3x, that's 4x. Negative 2 plus 2y, that happens to be right here, 0. So we're not going to put anything there. And then z plus negative z is also 0 as well. So we'll leave that blank. And then we got negative 11 plus 7, and that right there happens to be 4. So luckily on this, so far in this first example, 2 of the variables happen to go away. It's not always going to happen. Very rare. But it happened here. So let's go ahead and solve for x. And in order to do that, we should divide both sides by 4. And x is equal to 1. So we have figured out one of our variables. Next up, we need to take and choose another 2 variables right here. It could either be equations 1 and 3 or equations 2 and 3. It doesn't matter which one. But for me, sometimes there's always a better set of equations to choose. I find right here that actually I'm going to choose equation 3 and 2. Alright, so let me set up equation 3 on top. So we have negative x plus 2y plus 4z is equal to negative 9. And then right below that, I want to go ahead and put 3x plus 2y minus z is equal to 7. Okay, so those are the 2 equations that we're going to use this time around. We're going to add things up. Now, before you add things up, remember one of the things I said is if I eliminate one variable, in particular the first time, I have to make sure that that variable gets eliminated the second time around. If not, we're in trouble. If I look right here, let's say I said the first time around I want to eliminate the z, which I did. If I want to eliminate the z in this equation now, am I able to do that? If I just go ahead and add things together, will that be possible? 4z plus negative z does not equal 0. And so that doesn't work. So what you're going to have to do now is figure out, well, if I look at the coefficients of the z's, I've got 4 and negative 1, or 4 and 1. I have to figure out, well, what is the lowest common multiple? You may remember LCM. Right, so what is the lowest common multiple of 4 and 1? It's going to be 4. So in order for this to work, I need to take this bottom equation and multiply everything by 4. So let me go ahead and rewrite things now. And I have 4 times 3x is 12x. We've got plus 8y minus 4z. We're running out of space right here. Let me move everything over, or almost everything over. Hopefully you have more space. That's not what I want to do. Okay, there we go. And then this is equal to 28. So now let's take these 2 equations right here and add them up. And hopefully one of our equations, or z, will be eliminated. I'm taking a look right here. Negative x plus 12x. That gets us 11x. 2y plus 8y. That right there is 10y. 4z plus negative 4z is 0. And then we're left with negative 9 plus 28, which is going to get us 19 right there. Alright, so it looks like we're getting closer to what we need here. And actually, let's go back right here. And maybe you figured it out. We do have a problem with this. This right here, negative 11 plus 7 should get us negative 4. And negative 4 divided by 4 should result in negative 1. So, good thing we figured that out, or I did. This problem would have seemed a whole lot harder than it should be. So after we did that, we're going to now go ahead and take this and we're going to substitute that in. Okay, so we're going to substitute, and we now have 11 times negative 1 plus 10y is equal to 19. So we're going to go ahead and simplify this. I've got negative 11 plus 10y is equal to 19. We're going to add 11 to both sides so that we can try to get y by itself. 10y is equal to 30. And then right here, let's erase some of this. Divide both sides by 10, and y is equal to 3. So now, we have x and y. Last thing we've got to do is figure out what z is. Okay, so in step 3, it says, all right, we're going to go ahead and have to substitute everything in so we can find the third variable. So we have 3 equations right here. It doesn't matter which one you use, 1, 2, or 3, whichever one you think would be the easiest one and get us the result the quickest. Okay. Looks to me, I think probably the worst one is number 3. 1 and 2 are probably the easiest. They both have positive x and positive z. So let's go ahead and substitute things into equation number 1. So we have negative 1 minus 2 times y, which is 3, and then plus z is equal to negative 11. All right. So from there, let's go ahead and solve things out. And so I got negative 1, negative 2 times 3, negative 6, plus z is equal to negative 11. So that right there, negative 7 plus z is equal to negative 11. And we'll add 7 to both sides. And z right here is equal to negative 4. So we're pretty much done. There's one last thing. Remember, all these 3 equations, because we're able to eliminate them down or simplify them down to 2 variables, what that tells us is showing us 3-dimensionally, like these are probably 3-dimensional figures, planes, and where exactly are they intersecting? And what they're saying is that these functions, they're intercepting at 3 points, x, y, z, or at the coordinate. So we want to make sure we write it as an ordered pair. We got negative 1, x, 3 is y, and negative 4 is z. Okay? So there's your answer right there. I know, it's a lot of work. This one is probably the most challenging as far as mathematically in this section right here. Okay, so there's example 1. Let's take a look at example 2. Alright, so once again we have 3 equations, 3 unknowns. Let's try to eliminate one of our variables. Which equation should we use first? I'm looking at which ones has LCM. I see a 1z and a negative 1z. I think equation 3 and 1 is our lucky winner. So I'm going to go ahead, set things up. We've got 3x plus 2y plus z is equal to 0. We have x plus y minus z is equal to negative 1. Now remember, I set things up like this because when I'm adding, can I automatically eliminate one of my variables without having to find an LCM? And remember, one of them actually needs to be positive and the other one needs to be negative. So if I set it up like how I have 3 above and 1 below, I know that z will be eliminated. So let's check this out and see what happens. I've got 3x plus x. We got 4x right here. I've got 2y plus y. That's plus 3y. The z's cancel out and I end up with 0 plus negative 1, which is negative 1. So I have equations 1 and 3. Okay. I also need to have choose another 2 equations. Remember, it could be 1 and 2 or it could be 2 and 3. It doesn't matter which one. Let's try right here. I would say equations 2 and 3 might be better aligned because right here one of the variables for z happened to be positive and the other one negative. So let's set this up, and I'm going to go ahead and put 3 on top and 2 down below. Remember, part of the reason for that right here is because when I add things up, it's easier to add when the bottom equation happens to be negative. So we have 3x plus 2y plus z is equal to 0. Next up, 4x plus 4y minus 4z is equal to negative 2. We have to have right here, once again, our GCF. Or sorry, LCM, lowest common multiple. And so if I look right here, there's a coefficient of 1 and 4. That means hopefully the LCM right there of 1 and 4 is 4. So I'm going to take this equation, multiply it by 4. Right, every single part. So 4 times 3x, that gets us 12x. 4 times 2y is plus 8y. And I got plus 4z is equal to 0. So let's add these 2 equations up now. As a result, let's see here. We've got 12x plus 4x is 16x. We have 8y plus 4y, that's plus 12y. And then 4z minus z is equal to 0. And then 0 plus negative 2 right here happens to be negative 2. So we have 2 equations, 2 unknowns now. For our next step, okay, we didn't have to do this in example 1, but we're going to have to do this here in example 2, is since I still have 2 variables, 2 unknowns, what I'm going to need to do now is take the equations right here and pretty much do the same thing. Use the addition method to solve this out. So I'm going to go ahead right here, and I'm going to take 16x plus 12y is equal to negative 2. And then I'm going to go ahead down below, 4x plus 3y is equal to negative 1. And so we got to think, well, which variable do we want to get rid of? Okay, it doesn't matter. How about right here? Let's get rid of the x. So if we want to get rid of the x, I got to figure out what is the LCM of 16 and 4. And that right there is going to be 16. So that means I got to take this bottom equation and multiply it by 4. By multiplying it by 4, I end up with 16x plus 12y is equal to negative 4. And actually, if I add things together, does this work out? Because 16x plus 16x, that's no elimination. So how about this? We've got to make sure that we multiply the bottom by negative 4. So now I have, let's change our signs, negative 16x. This will be minus 12y, and then this will become positive 4. And then we still have the top equation, which is 16x plus 12y is equal to negative 2. So right here, all of this together, let's add things up. 16x plus negative 16x, 0. 12y plus negative 12y, 0. Negative 2 plus 4, negative 2. Does 0 equal 2 or negative 2 right here? I don't think so. This right here is false. If you remember in the very first page of our notes that I had you write down, it says that if the statement happens to be false in any step, which it is right here, our solution is no solution because they do not intersect with each other. Okay? Tricky, right? You still do have to put some work in order to get this answer, okay, or to get the correct answer here. Let's take a look at example 3. Make it a little more challenging. Looks a little more challenging. Let's do it. All right. You guys need more practice anyways. Right now, I'm looking at the x's, the y's, and the z's, and I'm saying, hey, with the y, I could add these two up and eliminate. So let's start right here with equation 1 and 3. So 6x plus 8y minus 6z is equal to 62. We have 12x minus 8y plus 20z is equal to negative 68. All right, so I choose these, and I have it set up as is because right here, when I add them up, I can automatically eliminate the y's. Okay. So we want to try to be logical, make things as easy as possible. And so 6x plus 12x, that's 18x. The y's cancel out. Negative 6z plus 20z. That'll get us a positive 14z. And that right there is equal to negative 6. So we got rid of the y's. So we have to get rid of the y's one more time. And it depends if you want to use equations 1 and 2 or equations 2 and 3. Remember, it doesn't really matter. You take your pick. But I do find that equations 1 and 2 might be better because if I look at the y's, one of them is already positive, the other one is negative. There's just a lot more work in this problem. The reason being is because we have to figure out, well, what's the LCM of both 8 and negative 12? So we have to do a little bit more work right here. So let's right here, I'll use equations 1 and 2. And I know I'm going to need a lot more space here. If we think about what is the LCM, okay, of 8 and 12, you could always multiply the two numbers together. Okay, that's always one option. So if you take 8 times 12, that right there happens to be 96. There might be a better one. Okay, so if you think about it, looks like if you take 12 times 2, that gets me 24, and 8 times 3, well, it can also get me 24. So instead of using a big number, by multiplying the two together, you might be able to find some others. But if maybe you're saying mentally you can't figure it out because you're just a little bit weaker in trying to do some of the mental math, you can always multiply the two factors together to find the LCM, but it may not be actually the lowest. It might be a common multiple, just not the lowest common multiple. So we figured out, okay, that we have 24 will be the LCM. So let's multiply this top and bottom by 3. We got, this will turn into 18x plus 24y minus 12z is equal to 62 times 3, which off the top of my head, I don't know, but it looks like it's maybe 186. All right. And then down below, we will need to multiply this by 2. All right, multiplying that by 2, we end up with 20x minus 24y minus 28z is equal to 28. So now we get to add these two equations up and be left with x and y. The numbers weren't looking so good. And so what ended up happening as I kind of was looking at the problem right here, this is where things get a little dicey. I have a circle there in green. That right there, 6 times 3 is not negative 12. This should be negative 18. So I'll come back to this part. Let's go ahead and add these two things together. So I got 38x, the y's cancel out, and I've got negative 18, and then we have ourselves minus 28. So minus 46z, and then that right there, we got 186 plus 28. So we have 214. So let's take this, we'll bring it over here, and then we got ourselves minus 46z is equal to 214. All right. Fun times. Nobody ever said that, I don't think, right here, right? So let's figure out, well, what works to try to get, we got to figure out our LCM. And so we could eliminate the 12 or the x or the z. Let's figure it out. All right, we got to go through this. 14 times 3 gets me 42. So that doesn't necessarily work. If we take 46 times 2, that gets me 92. Can 92 be divided by 14 nicely? It can't. So how about let's take 46 times 3, 138. Can I divide that by 14 nicely? No. We got 46 times 4, 184. Can we divide that by 14 nicely? No, it does not go in evenly. We'll try 46 times 5, 230. Divide that by 14. No. Alright, we keep going again. 46 times 6, 276. Does 14 go in that evenly? It does not. So this is the struggle with this problem. And what I found right here is that if I take 46, multiply that by 7, that gets me 322. So let's take this bottom right here. I'll multiply it by 7. And then I do know that And I realized that 322, when I divide that by this 14, it goes in evenly to get me 23. So we have to multiply this top equation by 23. So 23 times 18, we end up with 414. Just my luck that I picked this problem and it happened to be this difficult. And it happens. You know, this stuff is not always just peaches and where it's nice and easy. I know this video is going a little bit longer than necessary. And so right here we get ourselves negative 138. Let's go ahead on the bottom. We got 7 times 38. We got 266. We have negative 46 times 7. Once again, that's negative 322. And then 214 times 7. 1,498. Let's add things up. 414 plus 266. We get 680x. The z's cancel out. We got negative 138. We need to add 1498 to that. And we get ourselves 1,360. Let's hope it works out nicely. And it does. X equals 2. All that just for one variable, right? It's like, what gives? I wish I knew. Okay, so now that we found z, the next best thing is to we found x. I gotta find z. The reason being is because if I use these two equations, one of these two right here, all right, that will allow me, or actually I could even use one of these two because they're all smaller. I can figure out what z is, right? If I substitute in for x, I can find z. So I could choose one of these two right here, or even these ones. And let's choose the smaller numbers, okay? So we got 18 times 2 plus 14z is equal to negative 6. 18 times 2, 36, plus 14z is equal to negative 6. We'll go ahead and subtract 36 to both sides. So now we end up with negative 42. So negative 42, we divide that by 14. It works out nicely. Z is equal to negative 3. And finally, to find y, we will plug it into one of the original equations. Okay, doesn't matter which one, plug it into one of the original. So we have x is negative 2. Remember, z is equal to negative 3. Right, let me double check right here. Yes. Don't want to mess up here at the very end. So we got ourselves 6 times 2 plus 8y minus 6 times negative 3 is equal to 62. Alright, so 12 plus 8y plus 18, because negative times negative is a positive, is equal to 62. 8y, we could add 12 and 18, plus 30 is equal to 62. Subtract 30 to both sides, and we're left with 8y is equal to 32. And yes, when we divide both sides by 8, y is equal to 4. A nice number. And right here, our answer, 2, comma 4, comma negative 3, x, y, z. I'm done with this. Hope you are too. Do the best that you can. All right, you will be seeing more of this later on throughout throughout Algebra 2 in the school year. So we'll see it again. And I'll see you